Alright, we're going to try an example problem here. We're going to start with a solid plate. Get the focus in here. And we're going to have that plate have a radius of 2r. Then what I'm going to do is cut out a portion of that plate. So before I remove that section, the center of mass of that original plate is, of course, right at the center. And then if I cut out this disc, and actually kind of remove it, the center of mass of that disc is right in the middle of that disc. So from the center of mass of that disc, we're going to have a radius of r. Since from here to here is 2r, that's going to be half that distance. So that means the center of mass of this object is negative r from the original origin. Now, when I remove that piece, the center of mass of the rest of the object is going to shift to the right. We'll call this the center of mass of the plate. We'll call this the center of mass of the disc. And this will be the center of mass of the total added mass. Now, since this is a even distribution of mass, we technically use this relationship of all of the total masses of the different objects. Now, since the integral of all the little areas is going to equal the total area, we can think about these areas as particles. And then we can sum up the location of each object's center times the area of each object. So this turns into the x of the plate, the center of mass of just the plate, times the area of the plate, plus the center of mass of the disc, times the area of the disc, because those are the two objects that we're going to have. And that's going to be divided by the total area, which is going to be the area of the plate plus the area of the disc. All right, easier to think about it as just the total anyway. And this is going to give us the center of mass that is at the center. All right, so that's a total center of mass if we add up the center of masses of two separate objects. Now we know that this is at the center, which is 0. Now, that's 0. If I multiply this over, that's still 0. What that tells us that this is equal to the negative of this. So xp times ap is equal to the negative of xd times ad. And what we're doing is looking for xp. So let's solve this around for xp. Alright, so now we really just need to plug in what we know. We know that the center of mass of the disk is located a negative r away from that origin. The area of the disk is just pi r squared Now the area of this plate is going to be the total area minus the area of the disk. So that's going to be pi times 2r squared minus pi r squared. So if we work this out, we get these two cancel. We have pi r cubed on top. Here we have 4. So I'm going to just write this out. So we have 4 pi r squared minus 1 pi r squared. So that gives us 3 pi r squared. Cancels. Cancels. So we're left with r over 3. So that the center of mass of the plate is located 1/3 of radius r.